Okay, in example 3.4, we're asked to find the critical numbers of this function x squared minus 16 to the 4/5, and then find the intervals on which this function is increasing or decreasing. And to do this, we need to take the derivative using the chain rule. So f prime of x is going to be 4/5 something to the negative 1/5. So that's the derivative of the outside function. Then we plug in the inside function, leaving it alone, and then we multiply by the derivative of the inside function. Right, that's the chain rule, which we learned about last time. And so I can rewrite this as 2x times 4 is 8x over 5 times x squared minus 16 to the 1/5. So all I did was I moved that x squared minus 16 to the negative 1/5. I moved it down to make it a positive 1/5. So that's f prime of x. And now to find the critical numbers, we need to figure out when this is 0 and when it's undefined. It'll be 0 if 8x equals 0, so that's x equals 0. So that's the one time where the derivative is 0. And it'll be undefined if the denominator, 5x squared, 5 times x squared minus 16 to the 1/5, if that equals 0. So we set the denominator equal to 0 and we solve for x, and that'll give us our other critical numbers. So we multiply both sides by 1/5, or divide both sides by 5 to get rid of that 5 out front. And then you have x squared minus 16 to the 1/5. You can raise both sides of the equation to the 5th power. 0 to the 5th power is 0, so it doesn't really change anything. So we get that 0 equals x squared minus 16. You can add the 16 over. Get x squared equals 16, so x equals plus or minus 4. And so now we have three critical numbers, x equals plus or minus 4, or x equals 0. And now we need to plug in points to the right or left of every one of those points to figure out when the function is increasing or decreasing using the derivative. So if you take f prime of negative 5, you'll get 8 times negative 5 all over 5 times negative 5 squared minus 16 raised to the 1/5. That'll be negative 40 over, that's 25 minus 16 is 9, 9 to the 1/5, so it's 5 times 9 to the 1/5. And I don't really need to figure out what this is. I know it's going to be a negative number because it's negative on top and positive on the bottom. So it's negative, so that tells me I'm decreasing here. If you plug in a value between negative 4 and negative 2, or I mean negative 4 and 0, like negative 1, let's say, then you get 8 times negative 1 over 5 times 1 minus 16 to the 1/5. And so that's going to be a negative over a negative, so that's actually going to be positive. So this is going to be increasing because the derivative is positive. So the derivative is positive. That tells me that the function is increasing. On that interval. Okay, and then I'm going to plug in like f prime of 1, and I'll get 8 over a negative number, 5 times 1 squared minus 16 to the 1/5. So that'll be less than 0, so this is going to be decreasing here. The function is going to be decreasing, the derivative is going to be negative. And then finally, f prime of some number to the right of 4, like 5, is 8 times 5 over 5 times 5 squared minus 16 to the 1/5. And again, that's going to be a positive over positive, so that's going to be greater than 0. So then I know the function's increasing over there. So to summarize, this function is increasing from negative 4 to 0, union 4 to infinity, and it's decreasing from 0 or negative infinity to negative 4, union 0 to 4.